Hello, good time to you all. I'm back with the P4 Pandascanner for evaluating work on casts, the wireless scanner that you got to know in the previous episode. You heard about its features. And today, we will see how it performs on casts in practice. This wireless scanner weighs 238 grams, which is a very suitable weight. I've installed everything. Everything is ready to post the same thing on two different platforms. First of all, post the scan of the same cast, the same model cast, to see how it looks in the scan of Bob and in that OMG Afra that I drew in the Nane. How can our OMG Afra be scanned? And after that, we scan an implant case, a single node implant, to see how the scan is going. Let's go right away. To get started, I introduced the case on the software, selected the scan, and now everything is ready for scanning. In the previous episode, we talked about how the Panda P4 needs calibration to perform the scan properly. We want to have this calibration with us now. It is recommended that we calibrate it the first time we use the scanner. What 3D calibration does is that it can calibrate the positions of the scanner and the positions of the 3D scanner in contact with the object. I assure you that the device can detect the object in front of it, such as a tooth or a bone, and transfer the real-time position of the object to the software. For calibration, this scanner has such a component that I connected to my laptop with the help of a USB cable, and now everything is ready for calibration. This is the part where the scanner enters the program, and then with an automatic sequence, the scanner performs the calibration itself. For this purpose, I definitely need to remove the tip, our tête. And after removing the tip, I will use the guidance that indicates the direction to position the scanner correctly and align it properly. Let's see, each destination in this, I'm going to the parameters for calibration, and I will select the 3D calibration. This process is done automatically, and all you really need to do is position the scanner correctly and hit the start button. For your purpose, you need to turn on a scanner, and here in fact, I will turn on a scanner manually. And now everything is ready to start the calibration, or in the menu, in fact, I select the parameters here, calibration. Now the calibration process is ready to start with the automatic calibration phase. It will take about a minute or two. This process is what you need to do. This step is complete then. After printing to this stage, you can have explanations that the mirror and scanner in contact with the object being scanned can achieve a very high level of accuracy. The accuracy we expect for capturing the object's data and transfer this information to the software correctly. This scanner can scan objects with a resolution of about 15 micrometers and a precision of 10 micrometers, and this happens when your device is calibrated and receives the data quickly. We talked about this scanner. The weight is about 2377 grams. In fact, the weight of the scanner with its battery is very acceptable. You can cycle the tips up to 50 times, which is actually a free number for you, and you can get additional tips for it. The calibration is finished, and now the scanner is ready to use. I take the scanner off the dock, understand the calibration, close it, and I'm going to start the scan. I'm placing the tip in the correct alignment and setting it to start the dock. Let's go for the image acquisition. DEMA has been introduced. We are ready to receive number scan information. I want to start scanning the cast. What's the first step? Normally, the appropriate sequence for that is a mandibular scan, an upper jaw scan, a lower jaw scan, and 9 tons of scans. So we want to prepare a sequence together I'll turn on the scan, and now everything is ready to go. I have a few patches here. Let's talk about it. The first patch is the patch that can help you properly visualize the male tissue. This is a possibility that you can use if you want to improve the light. In the case where we have brown spots on the surface of the teeth and they have a lot of strain, like heavy smoker patients, this second feature can help them have a more successful scan. The next feature is feature 1, which helps in the case where we don't have teeth to be able to do a more successful scan on the surface. And the last feature is one that can warm up the tip for you if you're just starting out and want to specifically enhance the mirror and improve the anti-fog performance. This feature will help you. The heating helps the mirror warm up faster and improves the anti-fog performance. As for the scanning method itself, there are 3 different features here for you to optimize. Scan on a cast, scan on a resin model, and scan your teeth. These are 3 options that you can activate here. If I want to scan a resin in this position, if I want to scan a plaster cast here, and if I'm scanning a tooth, I can use this mode to actually adjust the data so that I can do a deeper scan. First, you can set your scan depth to be either standard or deep. For example, if you can scan a skin, this option should definitely be on deep. But you should keep in mind that when you scan deeply, the chance of capturing artifacts also increases. So you need to balance it based on your needs. You can adjust this every time. I'm setting it to standard. And of course, later when I want to go for the cavity, I will also try the deep setting. With that explanation, let's go ahead and start our scanning process. I'm picking up the scanner. Yes, the distance is ready for scanning. And as soon as I start, I will begin scanning the upper jaw, and the data transfer will take place. You also have a pleasant music option with the Panda to help you perform your scans in a relaxed manner. It's even been suggested today that you can do scans while meditating, which helps you skip some therapy sessions. At the edge, there's a successful scan. I'm moving to the left. There will definitely be information there that you need to fill out again. Here, since the sulcus is quite deep, my info may not be complete there. However, now I have good data. Now let me check the file. I'll press start and enter control mode. Now I control my file. Green areas show full data recording. I can revisit spots to complete them, like the buccal surface. Another interesting feature, especially for this plan, is useful. When scanning, we use monochrome view for accurate surrounding info. I'm rotating it and looking at the areas. And now I can go back to some spots to complete them, like the buccal surface. This product also has another feature that's quite interesting, especially if you're working with this plan. You might want to use this feature a lot. When we scan the bodies to ensure that all the surrounding information is recorded properly, we often select the monochrome scan view mode, so we can see more accurately. On this scanner, you can quickly access this view. I'm currently looking at the upper thinking scanner. I want to see the details. When the form is colored, a detailed circuit in it may not be sharp. I enter monochrome mode by pressing this button twice. You can get detailed information in this mode. And if everything looks good now, I can move on to the next step. To do that, I press this button for a few seconds so that the optimized file goes for the next scan pack. Now I'm in a situation where I want to scan the lower arch, and this is where I have a cavity that corresponds to the extraction of the 6th tooth. For this cavity, I prefer to use the deep mode and see how the scan works in this mode and how it can capture the depth of this cavity. Let's start the lower arch scanner again with our music. I had the scan at the lingual level of this edentulous trachea too. The scan was done very quickly and I had no problems. The proximal sound is a very, very key part of your prosthesis bag or implant bag. This proximal sound needs to be scanned minutely. And the most interesting thing is that it is very successful in the OMG section. I see one of the most successful of these scanners now in the OMG section. Scan. Because many times we could scan this section maybe halfway, but you see that this Panda Piper scanner is very, very successful in the OMG section scan. This can promise that in many cases of your post, you can be completely consistent. Get an accurate digital post from your lab. When it's gone, the picture and sound of the music fades. This is your guide to knowing when you should actually try again. Check your file in your angle so you can take a new image where it's not perfect and I'll complete it. And keep in mind that scanning on this cast with the rosary view is more difficult than what we'll probably see inside the mouth. It's a very good plan. The lower arch scan is complete. I'm going to press the setup button. Let me tell you, I've seen very successful results in the depth of this cavity. In different scans, we always rely on this feature for testing. Let me enlarge the image for you. As you can see now, I'm looking at the depth of this cavity. I've scanned the mesial cavity all the way to the end, and I've also scanned the distal cavity up to the point where my screw is located. I've seen this view much less in scanners. Right now, we're scanning from the margins of the adjacent teeth, meaning from the mesial marginal ridge of tooth 5. You can scan that cavity up to that surface, and now that they've selected the deep mode, you can see that the cavity is completely scanned. Let's do a little test here. I see this part and I'm going to erase it, and this time I'll switch to the medium mode to see how it performs in this mode. Let's check the standard mode. Let's see how it scans in the shallow mode. This is a good base to understand how our scanner is performing, and this feature that's been implemented on the software might work. Now that I've selected the shallow mode, as you can see, it's scanning up to halfway through this cavity. It's a good idea to know how our Scandinavian system worked, and this patch that is based on Haftar's software might work. Now that I've chosen the beautiful waterfall, as you can see, I'm scaling this piece halfway. Now, at this point, I've stayed longer, it's recording, but the depth of the cavity still isn't complete. I'm very close to the adjacent post. Now, switch to deep mode. I'll show the adjacent post. This picture is a picture that works. And I'll go back to the Naga pad and show you Bella Pastel. This shows that this is one of the best of these best. It's not just for starting the device, it really works, and that's great for me. Amid was a part of today's post. Many of the posts I scan in the clinic, and now I myself are generally scanned with the help of the product scanner. This helps to make the delivery of your post a very smooth and fast process. This is a feature that scanners are also moving towards and are constantly improving on such a feature because it is a real core need of every clinic. It was a very good test and it showed that it worked well. Let's take the product for testing. Then I'll just take it like this. I've got some pictures of the canine. I'll go to the canine. Okay, now there's enough data. The lingual is here. I'm seeing a little bit now. Okay. So, by pressing the key, I go to the next layer, the layer that we need to scan. The file is optimized and it goes to the next layer that needs to be scanned. In this case, with call 1 and call 2 on the left, you can see this. There's another interesting feature, dynamic bite. This is an option that helps take a video of the patient's bite and transfer it to the lab. which can make the other party's call clearer for the technicians who are working in the lab, I'll take bite 1. Bite 1 has been verified. I'm going to our next snap, bite 2. By pressing the button, I'm going to bite 2. Here, I'm starting to give a second bite on the opposite side. In the same position where the patient's mouth is closed, I'm going to the opposite side and also give a second bite. Okay, and the last step, which is also optional, of course, can be a dynamic bite. At this point, I can place the scan and ask the patient to start chewing. Imagine my patient has such a bite. This bite helps in this way that in the function, I can also receive this half, for example, his bite, and well, this helps the lab to be more accurate. It helps plan the occlusal contacts by providing a clear view of the alignment and positioning of the teeth. Now, I'm carefully moving to the opposite side exactly as planned, ensuring precision. Aileen is chewing gum. She's keeping it in her mouth. We need to see how this data is transferred to the laboratory and what kind of file is actually being sent in this amount. My work is complete. I'm going to finalize it. Well, Dataproof Sync has evolved. It will have a minute of time, and during this time, I'm actually waiting for the file to be complete and finalized. In a way, the information is now being finalized. The rendering is being taken, and it's being prepared to be sent to the lab. This process, which you have seen many times, is almost common in all browsers. After using the program, we choose what kind of file we want to extract, whether it is a file, or a file format, or a combination of all of these, and also where the file information can be stored. Do you want to save it on your computer or a file server? That means leave it to Fuzzly Panda and write poetry with the laboratory. These are the choices you have at this point, and you really need to have one of them in the program. The file is finalized. Your patient still needs to be seated. Every time you emphasize this, the patient needs to stay until the end of the work to make sure everything is correct, and then the patient is targeted. In particular, be sure to check your bite at the very bottom of the work. You've recorded the bite scan in a limited area, and on the opposite side, your bite isn't correct. Open your bite or check for any discrepancies in the upper and lower data. You might have found a false deep bite in your model, and it's crucial to finalize the work when you're sure everything is accurate before you dismiss the patient. Here you have this fun and functional feature. You see the function. This is actually the motion control that we used to receive on, for example, our tree ship. Now on this model, you have this motion control. You see, it's kind of like a post with the name, or rather it's been deleted and the name has been mentioned here. And if everything is okay, now we can go to the file to send it. From this question, now the patient's information is definitely a part of what plan you have in your custody. It is also a part of what the data format is. For Afzal, it is also a part of how the file is actually sealed. For him, the model builder modeled the file or not. Now the program is set up to seamlessly transfer directly to the local design software. It can directly attestate and effortlessly open the file in the software that you have specifically assigned on this system for your design purposes. I hope to save the data. Under what specific name? Under the name Asman. As you can see, this project consists of several files, including the upper scan data, lower scan data, and the motion control tray shape, which is specifically designed for use in dental systems. When transferred to other software, it definitely has its own requirements. However, for this product, I will receive the data with its details and pass it on to you. All right, this is my first scanning experience. I had the fast and convenient CAS scan model car. In Proxima, I needed a little bit of a facelift, which I think was due to the transparent nature of this person. And the key thing that was so appealing to me about this was the successful scanning. that he had in him and the pores that could help us scan the pores of the skin fairly? Well, of course, here I have a weak wide, and there might be some challenges in reducing the width and dealing with the cavities, but as I mentioned, I always use the scanner for posterior scans in the clinic, and it performs quite well. I'm optimistic that this product will also showcase its capabilities effectively. All right, let's add this phase and move on to the next part. All right, let's start again. In this part, to review the Panda P4 operation as a sample from the Panda company. On an implant model, I have a dental implant core number 21, and I've selected this treatment plan. It's always ready to start the scan. So, when we have an implant case, in addition to the usual scans, which include the upper and lower jaw scans, we also have an additional scan called the scan body for the upper jaw. I've selected that, and everything is ready to start the work. Here, I'm going to set a normal angle, and I will select the tooth scan for the upper jaw. Everything is ready, and I expect a good scan. Let's wrap it up quickly and keep it concise. He likes a better scanner, the Pandaro scanner. My scanner doesn't like it very much, the Castamon scanner. Why scan plaster? Often in labs, there's a need to scan plaster cast, which involves pouring plaster over an alginate mold and scanning it. In implant cases, precise interproximal contacts are crucial for crown changes, and delays can occur in adjacent teeth in the plaster. Software may resolve this issue more easily. Let's check the scanned areas together. The palatal side can be improved. I'm reactivating the scanner quick, and the file is ready for the next step. Next, I want to scan the lower jaw. I press a button to start the body scan phase, addressing the implant area. I'm working on the file. In the chalk sample, I can say that there is some delay. Now, I hope that this problem can be easily fixed in a software way. Let's look at the file together. We can check the problems that have occurred. At the league level, Paltal can be used. In fact, Paltal has made this aspect a bit more complete. I'm activating the scanner. It scans fast and the file is ready. Next, I go to the lower jaw. I press this button to start the body scan, preparing the file. In this step, I mark the implant area. It optimizes. Next, I clean around the implant and adjacent teeth from the scan data. To attach and capture body scan data, I rotate it to view opposing teeth and widen it. For this step in the scan, I actually need a body scan to outline and mark the implant region. It optimizes the area, in the next step, which is the body scan, I need to erase the region around the implant, the dental region of the biceps, nor from the scan data. Why? So that I can attach the body scan to it and capture the body scan data on top of it. I need to rotate it. I want to position it in a way that I can also see the opposing teeth of the implant. And I also want to make this a bit wider. I'm completely cleaning this area with the eraser. I don't want to interfere with the body scan that I want to attach now, and I'm connecting my component to it. In this step, I want to add the implant data to the previous file. We have a layer of information from the upper jaw scan, and now we want to add some new information to it. That's the position of our implant. Well, there's a wind scan that helps me locate the implant. Save the information to the MRI scan file. I'm activating it. And the body scan starts quickly. The scan data, both in the proximal areas and the palatal areas, will be added to the file. If you find that the data is complete on this body scan, the file is ready to be sent to the next stage. I'm moving on to the next scan, the lower jaw scan. Press for a few seconds. Our next scan is the lower jaw scan. I start the scan by giving an overview of the entire area, then begin to complete the data in the areas. The scanner provided a smooth scan of the lower jaw, ready to proceed with the next scan. Stop the current scan, then move on to the next phase, the scan of the upper jaw. Go for the upper jaw scan, press, and the scan starts. The connection happens quickly, and I move on to the other side, start the scan for the second side. It's important that the scanner provided a very smooth and good scan of the lower jaw. Now I'm ready to move on to the next scan. First, I need to stop the current scan, and then by pressing this button, I will proceed to the next phase, which is the scan of the upper jaw. For an implant case, I need to go for the upper jaw scan. I press the scan button and the scan starts. The connection happens very quickly, and with a bit of pushing, I move on to the next step, which is the other side. I start the scan for the second side. I need to start the scan. The scan begins, and the connection happens very quickly. With a bit of pushing, I move on to the next step, which is the other side. I'm starting the second scan now. I need to verify both of them, and with the help of these two, I should be able to ensure that everything is ready for the laboratory work. In the laboratory work, I still want to use the dynamic bite feature. I just gave it a linear bite, and it's actually closing the teeth. If this stage is complete, the file should be ready to send. Then it can show the same person what movements it was able to do now that the laboratory was able to do those movements. It should give you and me a better idea as a way to move around. Although I actually chose the scan-based approach, I had some problems that were really annoying. The hardware is definitely not the nature of it. I understand that maybe it's software to some extent, maybe it's the scanning part. That still needs to be optimized, but here we can see that the scanning thought up and down in the node gave me good data. I put a circuit, more time for the torque, and this must be sick. It must be bad. But in fact, you have a circuit in the node that also puts it on the center, so maybe this will help. Lateral movements can be checked, and if there is any interference in the bites, it can be identified, which can help with the design. If the design is accurate, it may help. Our information is sufficient, and we will go ahead and send the file information to the next step. Where do I want to save it? On the desktop, please save it, and save it in this folder. Okay, all 37 megabytes of the total output volume of the pill Y, with that dynamic motion that actually happens when the Sabbath is given. This entire file is ready to be sent to the lab so that they can give you a proper overlay. At the end of this video, I need to thank, as always, the good Sam Featuremang for their help in capturing this product. I need to thank Nutrident, the company that developed your Panda product in the country, for making the preparations for recording this video for our product. I thank you, dear Framuni, on your behalf. I hope you found this video useful and useful. Be sure to follow the product. You should see how Panda Piper will do inside the mouth. I will definitely invite you to watch this video in the next video. I hope that if you are interested in a wireless scanner, Panda Pay4 will be a suitable solution for you. Hello, and take care.